in the last lesson, I explained how to convert from mass into moles and from moles into mass. And in the lesson before that, I explained how to convert between moles and particles. Now we're going to put it all together. And I like showing this wheel. You're not going to be given this on a quiz or test, but it is a nice graphic for you to really understand how to convert. So ultimately what this is showing you is that moles are your central unit. So I can go from moles into grams pretty easily. We did that last time using molar mass. I can go from moles into particles using my Avogadro's number. However, I cannot go directly into grams, from grams into particles. Instead, what I'm going to have to do is I have to go from grams first into moles, then from moles into particles. Or if I wanted to go from particles to grams, I would go from particles first into moles, then from moles into grams. So a lot of these problems are going to be two-step problems. Okay, so what I'm going to do, we're just going to run through problems. Okay, I will briefly reference this diagram here. I don't love it. The main point of it is to show you the importance of noting that your mole is your central unit if you're wanting to go from particles into grams or from grams into particles. Okay, so let's look at example number 1. How many moles are in 3.4 times 10 to the 24th molecules? So I'm going to set up by writing my given. Okay. I'm going to get out of molecules by putting it on bottom. Okay. And if you notice, I can go directly from particles into moles, and it'll just be one step. So I'm going to do that right now. Okay, so I'm going to put moles on top. What's the relationship between moles and molecules? Well, Avogadro's number. 1 mole is 6.02 times 10 to the 23rd molecules. So I need to take my given, which is 3.4 times 10 to the 24th, and I need to divide it by 6.02 times 10 to the 23rd. Now keep in mind you want to keep the 6.02 times 10 to the 23rd in parentheses when you divide. And the value that I get unrounded is 5.6478 moles. Okay. Notice I want 2 sig figs, 1, 2, 3. So I want a total of 2 sig figs. So this will just round to 5.6 moles. Okay. So that one actually wasn't a new problem. It was just a one-step problem, keeping you on your toes. All right, let's look at the next problem. All right, so in this problem, I'm in grams of aluminum sulfate and I want to get into formula units. So what I'm going to do is I'm going to go from grams first into moles, then from moles into formula units. Okay, so let's do that. So I'm going to go from grams into moles. I'm going to put grams on bottom, moles up top. Then I'm going to go from moles into formula units. Okay. In order to go from grams into moles, I need to determine the molar mass of aluminum sulfate. And to do that, I need to know the formula of aluminum sulfate. So I'm going to have to cross charges. Aluminum's 3+, sulfate is 2-. So the formula for this compound is Al2 in parentheses SO4 3. Okay, so I am just going to explain in words how I find my molar mass. I'm not going to write it out. So aluminum has a molar mass of 26.982. I'm going to multiply that by 2. Then I'm going to add to that the molar mass of sulfur, which is 32.066 times 3. So I have 3 sulfurs. And then I'm going to add to that the molar mass of oxygen, which is 15.999, and multiply that by 12 because I have 12 oxygens. And the molar mass that I get for aluminum sulfate is 342.15 grams per mole. Okay, so that value is going to go on bottom, 342.15 grams for every 1 mole. Then for the formula unit mole relationship, that is Avogadro's number. So 1 mole is 6.02 times 10 to the 23rd formula units. Okay, so I'm going to take 30. I'm going to divide by my molar mass, and then I'm going to multiply by Avogadro's number. So the value that I get for my unrounded number is 5.278 times 10 to the 22nd formula units. However, I want to have 2 sig figs from there. That has 5. That has 3, so I want 2 sig figs. So this is going to round to my final answer, being 5.3 times 10 to the 22nd, and my units are formula units. Okay, let's look at the next problem. Okay. For the next one, it asks how many grams are in 1.25 times 10 to the 25th molecules of carbon dioxide. So I'm first going to write my given, which is 1.25 times 10 to the 25th molecules. Okay. And let's go back and look at my chart in order to determine the steps I need to make. Okay. Well, I give you molecules, so you're starting over here. So I need to go from molecules into moles, then from moles into grams. So it's going to be a two-step problem again. I'm going to put molecules on bottom, and I'm going to put moles on top. I don't want to stop at moles though, because I need to get into grams. So I'm going to put moles on bottom, and I'm going to put grams up top. Okay. The relationship between molecules and moles, 1 mole is 6.02 times 10 to the 23rd molecules. It's Avogadro's number. For the gram to mole relationship, however, I need to determine the molar mass of carbon dioxide. Well, carbon dioxide, the formula of it is CO2. Okay. So carbon has a molar mass of 12.011. Oxygen has a molar mass of 15.999. I'm going to multiply that by 2, the 15.999, because I have 2 oxygens. And so what I get for my molar mass of carbon dioxide is 44.01 grams per mole. Okay. So I'm going to put the molar mass, 44.01, in front of grams. There are that many grams for every 1 mole. And so that the answer I get, I'm going to take 1.25 times 10 to the 25th. And I'm going to divide that by Avogadro's number. Now make sure that Avogadro's number is in parentheses. And then I'm going to multiply by the molar mass, 44.01. So the value that I get unrounded is 913.8 grams. 1.25 has 1, 2, 3 sig figs, 1, 2, 3 sig figs, 1, 2, 3, 4 sig figs, so I need 3 sig figs. So this is going to round to 914 grams.